Alright, so now that we know kind of the general layout of our periodic table, let's start to look a little bit closer at some of what those actual symbols are on, that are on the periodic table, right? So what we've got here is we've got one of our elements, the symbol, blown up. And what we can see is that there's lots of different information all on this symbol, right? So first off, the big one that we see in the middle, that C that stands for carbon, that's going to be our element symbol. What we know with our element symbol is that there's always going to be either one or two letters, and the first letter is always going to be capitalized. The second letter, if it has one, is always going to be lowercase. All right? So for us to make sure that we know which elements we have, we need to make sure that we use this formatting and we can differentiate between our capitalized letters and lowercase letters. Once we have our element symbol, if we look over here, this number 6 is actually what our periodic table is organized by. It's organized by the atomic number. Okay, and what we'll see as you go left to right and then down, you'll see that we go 1, 2, 3, 4, 5, 6, 7, 8, all the way across and all the way down to 118. Okay, so our periodic table is organized by the atomic number. Up here, right, you can see that this is not this number has numbers past the decimal point. I can't think of words right now, but this is our average atomic mass. Okay, and we'll start talking about this average atomic mass when we talk about isotopes. Okay, then we have two more things here, and these have to do with charges and with electrons and protons. So we'll talk about that in a second. Up here, these are charges that we see. So carbon, when it is a compound, generally it's going to have charges of either -4 or +4, and sometimes +2. Maybe sometimes there's some really weird compounds, but generally these are our most common charges for carbon. And then we have what's called our electron configuration. Okay, and our electron configuration we're going to talk about next unit. All right, so we also want to know on here about our nucleons. We'll talk about this in just a second, but our elements are made up of 3 subatomic particles. Okay, we have our protons, our electrons, and our neutrons. Okay, and we'll talk about how we kind of know about these later. But first off, our protons, has a charge of +1. Okay, the relative mass, protons weigh really small amount, but the relative mass is going to be 1 atomic mass unit, or AMU. Okay, this proton is going to be a nucleon because it's located in the nucleus. Okay, so nucleons, we know that we have protons. Okay, and our symbol for protons is either going to be P plus or just P. Okay, and our way to calculate our number of protons is actually just using our atomic number. All right, so our elements are actually determined by the number of protons that are in the nucleus, right? Which element we have is determined by the number of protons. All right, let's talk about our electrons here. Electrons have a -1 charge, so they kind of cancel out with our protons. Relative mass. Electrons are super, super, super light, even way lighter than our protons. All right? So much so that we're essentially just going to say that it's 0 mass. It has a really small amount of mass, but compared to protons, it's so low that we're just going to round it and say that it's 0. Okay? The location, electrons are not in nucleus. They're found outside of the nucleus. And they're going to be in electron clouds. All right? So they're outside of the nucleus. And then the symbol for electrons, I'm always going to use a lowercase e with a minus. All right? So how do we calculate the number of electrons that we have? Well, like I said, electrons and protons, they kind of cancel each other out with their charges. So if we have an atom that is uncharged, right? If it's just an atom and it's uncharged, it's going to be the exact same as protons. Okay? But if it is charged, we have a formula, okay? And you can use this formula all the time. We know that protons, P+, plus electrons is going to be equal to the charge, right? So if our charge is 0 and we have an atom, then these two have to be equal, right? So protons and our electrons, when we add them together, they have to equal the charge. Our last piece, our neutrons, right? Our neutrons, they don't have a charge. They're neutral, okay? But they do have mass, and it's about the same. It's about the same as a proton, right? Neutrons, as you might guess, are also located in the nucleus. All right? So our nucleons then are protons and neutrons. All right? And my symbol for this is going to be just N. And our way to calculate it has to do actually with our atomic mass. Right? But our atomic mass, like we said, our neutrons and protons have roughly the same mass. So what we can do is take our atomic mass and subtract our protons to get our neutrons. All right? So if we go over here, right, we can use the information to help fill in our chart. All right? So let's look at this chart here. First off, we have a symbol. This symbol would be chlorine, right? And it's chlorine 35. What that means is that our mass number, our atomic mass, is 35. Okay? Chlorine, when we go look at our periodic table, has 17 protons. And so 35 minus 17 means that we have 18 neutrons. There's no charge on chlorine, right? So it's just the atom. So our 17 protons means that we have 17 electrons, right? Our atomic number, like I said, matches our number of protons. The nuclear charge, right, would be plus 17, and our electrons is going to be minus 17. So our overall symbol, our nuclear symbol, we have chlorine here. We have 17 protons, and that's our atomic number down in the bottom left. And then we have 35. That's the mass, our atomic mass, or our mass number for that chlorine atom. Okay? So, let's go ahead and go through and let's try and figure out this next row. If we have 15 protons, how many electrons are we going to have? 15 as well. All right? So now, if we have 15 protons, what's going to be our atomic number? That's going to be 15 as well, right? Our number of protons is equal to the number of is equal to the atomic number. Our mass number, now this is our atomic mass, and this is based on the nucleons, right? So we have 15 protons and 16 neutrons, That means that we have 31, our mass number of 31. What's going to be our nuclear charge? Our nuclear charge is again going to be equal to our number of protons, right? Neutrons are in the nucleus, but they don't have a charge. So our nuclear charge is going to be 15. Okay, now we want to build our symbol and our nuclear symbol. So the last piece that we need to do is we need to figure out what is our element. What element do we have? Well, if we look, our atomic number is 15. If we go to our periodic table, we find that it's phosphorus. So we have phosphorus, and what's the mass number for it? 31. Whoops, I didn't. So it's phosphorus 31, kind of same sort of format as our symbol up there. So let's get our nuclear symbol over here. We've got our phosphorus there. We need to put our atomic number in the bottom left. Our atomic number is 15. And then in the upper left, we put our mass number. So that's 31. So we should be able to then fill out the rest of this table.